Hey guys, welcome to the video for day 12. Today we're going to talk about reading graphs. So there's a graph on the right here and we're going to look at some information from it. A graph models Craig's trip to visit his friends in another state. In the course of his travels, he encountered both highway and city driving. Based on the graph, during which interval did Craig most likely drive in the city? And explain your reasoning. So if I look over here, I think that when I look from across this graph, I can see that from A to B and from C to D, he's traveling pretty quickly compared to D to E because the slope here is like a lower slope. So I can see here that he traveled less speed over the time compared to here where he covered a lot of miles in a shorter time. And then here, this shows me that from 2 hours to 3.5 hours, this miles he traveled is exactly the same. So that tells me something probably happened here where the miles didn't change. So where do we think that he most likely traveled in the city? Well, if I think of the city, driving in the city means that there's a lot of stopping, can't go as fast as you can on a highway. So I think from D to E, Craig drove in the city because he traveled fewer miles per hour compared to the other lines. The next part says explain what might have happened in the interval between B and C. From B to C, like I said, the miles traveled is the same. So I think that Craig probably stopped to eat, and the reason I say eat is because it was an hour and a half, so it's not just a short stop. He's there for an hour and a half. Determine Craig's average rate of speed. Well, this one has that average rate of speed. What does that mean? Above that, I always like to write slope. That tells me that I'm looking for the slope to the nearest tenth of a mile per hour for the entire trip. So that means starting at my 0 point and going all the way to E, which is the point 230. So I can use rise over run or the slope formula to find this. So remember, you can use the slope formula, but I can see that he rose 230 miles, and that was over the 7 hours. So then it's a job for my calculator, 230 divided by 7, which is 32, and then I have this long decimal that I just copied out of my calculator. Now I need to round to the nearest tenth, so that's why I didn't math frac this, because they told me that I needed to round. So when we round to the nearest tenth, that means I'm looking at the tenths place, which is the 8, and when I look over at the 5, that 5 is telling me to go up. So my final answer would be this 32 and 9/10 miles per hour. Okay, this next question says that I need to look at the graphs, and Morgan can wrestle at age 5 in Division 1. He then remains in the division until his next odd birthday when he is required to move up to the next division level. Which graph correctly represents this information? Well, if I look, I need to see that at age 5, he can start in Division 1. So looking at my options, choice 1 here starts with a closed circle at 5, if I look at the 5 value right here. And then at 3, there's also a closed value at 5. In 2, at 5 years old, this shows me I can't actually start at 5 years old. So this open circle makes me think it can't be 2. And then similarly, if I look at the graph for 4, at 5, there's an open circle, so it's not 4 either. So between 1 and 3, well, when I look at the next odd birthday, so his next odd birthday here would be 7. So at 7, he must move up to the next level. Can't stay in Division 1 at age 7. So I think it's 1 because there's an open circle for Division 1 at age 7, and at age 7, you would move to Division 2. So the correct answer is 1 here. Okay, question number 3 says that Samantha purchased a package of sugar cookies. The nutrition label states that each serving size of 3 cookies contains 160 calories. Samantha creates the graph below showing the number of cookies eaten and the number of calories consumed, and it's actually to the right here. Explain why it is appropriate for Samantha to draw a line through the points on the graph. So they're telling you that we would need to. And we've talked about situations where we didn't have lines. For example, there was the question where we talked about buying coffees. Even if you don't drink the entire coffee, you still have to buy the coffee. Situations like that mean that we would just have points. But if we think of this situation and they're telling us, I want a line through it, why is that appropriate? So this would be what my graph would look like with a line and an arrow to the right because the number of cookies eaten can continue to increase. They can't go in negatives though, so that's why there's no arrow on this side. So why is that? Well, because she doesn't have to eat 3 cookies. She could eat 2 cookies or maybe half a cookie over here. Like she can eat parts of cookies. So I just wrote that out as Samantha does not need to eat cookies in groups of 3. She can even eat part of a cookie. Maybe she can, I can't. But we could have, say, half of a cookie. So that's why it would be appropriate to have a line through there. Okay, question 4 says, to keep track of his profits, the owner of a carnival booth decides to model his ticket sales on a graph. He found that his profit only declined when he sold between 10 and 40 tickets. Which graph could represent his profits? Well, to answer this, I need to look between 10 and 40 tickets. So which part of the graph is that? So the first thing I did was highlight the 10 to 40 in each graph. And we're looking for it to decline. So for this first one, that's staying the same. For number 2, between 10 and 40, it's increasing. For number 3, 10 to 40 is decreasing. So I think that's the correct answer. In 4, if I look between 10 and 40, it's increasing and then decreasing. And it's even decreasing past 40. So the correct answer is 3. That's the only one that shows only a decline between 10 and 40 tickets. Okay, the next question says that this graph shows an object's distance change with time. What was the object's total distance? Well, if we look over here, the distance traveled, it starts over here, it goes out 20, and then it comes back down this way, 20 meters again. So that's a total of 40. So remember, that was the total there. What was the object doing between 15 and 20 seconds? Well, if I look on my graph, that's that part C at the top here between 15 and 20. So we can highlight that part. And then what do we think is happening? Well, we have to look over at the Y to figure out what that is. That's the distance. So from 15 to 20, the distance remained the same. So that means the object was not moving between that time. When was the object moving at the fastest speed? Well, to answer this, you can either look at the steepness of each slope or you can actually calculate it. I think that part A and part D both look like they're pretty similar. So I'm going to find what those slopes are. This one is rising 15 over 5, so that would be a slope of 3. Now if I look at D, for this one the slope is a change in 20 over 10 seconds, so that would equal 2. So during which interval is it moving the fastest? That would be A, because it's traveling further over a shorter amount of time. So the slope is the fastest there. When was the object moving at the slowest speed, but still moving, not standing still? So that would be B from 5 to 15 seconds, and I also added the A from 0 to 5 seconds just so you know what it means in the context of the problem. Okay, number 6 here says that this graph shows an object's speed in miles per hour over time. What was the object doing from 7 to 10 hours? Well, again, I need to look at the graph to find out where is the 7 to 10. So 7 to 10 is up at the top here. So that's this part right here, 7 to 10. Well, what's happening? We need to look again over at the Y's. That's a speed in miles per hour. So this doesn't mean that the distance didn't change. This means that the speed, 40 miles per hour, stayed the same over this time interval. So the speed remained constant. Over what interval was the object speeding up? So when was it increasing? Well, if I look over at my graph, it was speeding up. The miles per hour was increasing all the way from 0 up to 7 hours. So I wrote that out from 0 to 7 hours, and the interval for that is 0 is less than x is less than 7. And remember, we talked about how at 0 and 7, it's neither increasing nor decreasing. The next one says, well, what interval was the object slowing down? So if I look over here, it's slowing down starting at 10 and going till 13. So a similar answer there from 10 to 13 hours, and the 10 is less than x is less than 13. How come the horizontal portion of the graph means something different in question 5 than it does in question 6? We already talked about this. It's because when you look at the y-axis, the one graph is looking at the speed staying the same and the other is the distance staying the same. So you always need to look at the y-axis to determine what they're talking about and answer those questions correctly. Okay, we'll do more of this tomorrow, so have a great day and we'll see you tomorrow.